Hello and welcome to another edition of Mr. Chappell's Chemistry Screencasts. Today we're going to learn about writing electronic configurations. What you'll learn today is how to label a periodic table for electronic configurations, and how to find the electronic configuration for any element. Now, there are a couple of things you're going to need. You're going to need a periodic table, and you're going to need some coloring pens or pencils. Let's go ahead and get started. Well, here we have our periodic table, and the first thing we want to do is we want to label down the four blocks of the periodic table. That's the S block, the P block, the D block, and the F block. So let's start with the S block. And the S block includes families 1 and 2, and you have to remember to include helium with that. It's actually part of the S block. The next block we're going to label is the P block. And that includes everything from family number 13 all the way to family number 18. And in the middle, we're going to have the D block. And that includes all the transitional elements. And for our last block, no prizes for guessing, this is going to be the F block. Now the next thing we need to do is we need to label down some numbers next to each of the blocks. Let's start with the S block. We want to put the number 1 next to hydrogen, number 2 next to lithium, and stop me if you see a pattern here. We go all the way to number 7, francium. Now for the P block, we're going to start with number 2, and that's going to be next to boron. And it's probably a good idea to put the 2, or put all these numbers that is, right on the line. Next to aluminum of 3, next to gallium of 4, 5, 6, and then lastly a 7. For the D block, we want to put a number just to the left of scandium, number 3, number 4, number 5, and number 6. And lastly, for the F block, we want to put a number 4 next to cerium and a number 5 next to thorium. Now let's go through with a couple of examples. Here we are, and the first electronic configuration that we're going to write out is for the element oxygen. That's number 8. And what we need to do is start immediately to the left of hydrogen and go forward by atomic number until we land on oxygen. So we're going to go hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. So the first number we run into is a 1. We're at the S block, so we write 1s. We're going to cross two elements, hydrogen and helium, before we run into our next number. So we write 1s2. The number we run into is a 2. We're at the S block, so we write 2s, and we cross two elements until we run into our next number, so we write 2s2. The number we ran into is a 2. We're at the P block, and we just have to count over to oxygen. 1, 2, 3, 4. So we write 2p4. It's important to include the element that you're shooting for in that count. Now the next example we're going to do is for silicon. Silicon is number 14, and that's going to be a lot of terms, but we don't need to write them all down. We're really just interested in the valence shell. So what you do is you find silicon, and you count backward by atomic number until you run into your first inert gas, which is going to be neon. And you write brackets neon. That represents 10 core electrons. They aren't going to do very much, so we're just going to abbreviate them. And then you start the process from there. The first number we run into is a 3. We're at the P block, so we write 3p2 because we crossed two elements. And the next term we run into is a 3. We're at the P block, so we write 3p, 1, and then finally 2 with silicon. Now for zirconium, number 40, We're also going to back up until we run into our first inert gas, and the first inert gas we run into is going to be krypton. So we write brackets krypton. Then we start from krypton, we go to 5s2, and then finally 4d2, ending with zirconium. Now for xenon, number 54, you might think that's pretty easy. It is an inert gas, so we just need to write down bracket xenon. But unfortunately, the rule is you have to spell out the valence shell, even if it's not going to be doing very much. So we need to start at xenon and back up until we run into our first inert gas. And that first inert gas is going to be krypton. So we write down brackets krypton, and then we write 5s2, 4d10, and then finally 5p6 with xenon. Now for our last example, I picked the hardest one, or one of the hardest one. This is Mr. Mercury, number 80. And once again, we back up until we run into our first inert gas, and that's going to be xenon. We write brackets xenon, 6s2, 5d10. Now you might think that we're done, but you'll notice right here there's a gap in the atomic number between 57 and 72. So we need to tack on one last term. We need to go find 58 and write down 4f. And we're going to cross all the f's, and there's a total of 14 of them, before we go back to number 72. So our last term is 4f14, and then you're done. And that concludes our lesson. It's joke time once again. Hey, do you know what hamburger and electrons have in common? Well, they're both in the ground state.